everyone. Welcome back. I'm hoping you're having a lovely afternoon. I do apologize for the EMP that must have struck our school. It took out all our electronics. Usually, we're usually doing activities with internet and videos and whatnot. Today we're going to kind of kick it old school, and I'm just going to talk to you about each of the planets, the terrestrial and the gas giants, give you a little bit of information for the project you're going to be doing later, because I know you may not focus on the other planets if you don't get a little bit of information about them first. Now, if you remember, we are just starting the Space and Space Exploration Unit. Yesterday, we covered Earth, we covered the Sun, we talked about the dimensions, and we talked about the definition for what makes a planet a planet. Now, before we get on to Mercury and Mars and all those other good planets, let's go back to yesterday. What are the three characteristics that NASA wants to see that defines planetary status? Just shout it out, anyone. Thank you. It has to circle the Sun, it has to orbit the Sun. First characteristic. It's the second characteristic, the one that got Pluto demoted. It has to clear its orbit. Pluto can't have any other objects moving in and out of the orbit or anything like that. And the third characteristic, I think that most people forget, is it has to form under its own gravity. So it has to form a spherical object. That's why a lot of asteroids and comets that may clear their orbit, that may circle the Sun, that's why they're not planets. Okay, so let's get into the first of the terrestrial planets. Let's get into Mercury. Mercury, it circles the Sun faster than any of the other planets, which is why it was named after the Roman god for speed or swiftness, the messenger god. Mercury's temperature, if you're standing right there on the surface, right in front of the Sun, you're cooking at 450 degrees Celsius, and in the shade, minus 170. As you can guess, there's no atmosphere. Mercury's way too close to the Sun to have an atmosphere, and also size-wise, Mercury's just slightly larger than the Moon, so it doesn't really have the gravity it needs to trap an atmosphere in. Also, another very interesting thing about Mercury, it spins much slower than some of the other planets. At 59 days it takes to make a single rotation. So if you're standing there cooking at 450 degrees, you're standing there cooking for 59 days, just for one day to pass. That's how slowly it rotates on its axis. Interesting point, if you're thinking about doing Mercury in the future, they did find ice particles. NASA found them in 2012, but I will let you tell me more about that later if you so choose Mercury. The next planet in the system coming up is Venus, another Roman name given to this planet, named after the god of beauty and love and lust. The planet, it's the hottest of all of them, which you would think it was Mercury, because Mercury's closest to the Sun, but Venus is very, very volcanic. It's blowing out tons of carbon dioxide, which has just choked the planet into what you would consider like a runaway greenhouse to the extreme. And so the atmosphere, very, very, very heavy carbon dioxide and very, very thick. And that adds to pressure. Standing on the surface of Venus would be like 3,000 feet underneath the sea. You are just being squished, you are just being cooked. It is brutal. Another interesting thing about Venus, it's also a very slow spinner, even slower than Mercury. Venus takes, how much does Venus take? About 423 days for it to make a single rotation. And you would think that's incredible, but being on the surface of Venus, you wouldn't actually realize it. Because like I said, that thick atmosphere, that thick cloud cover makes a constant temperature on Venus. It doesn't matter, there's no weather, there's no night or day, there's no summer or winter, because it's just this own little universe underneath the cloud that doesn't change depending on its distance to the Sun. Okay, so that'd be something interesting to think about on Venus, how it is quite different than the other planets. We're going to skip Earth, because like I said, you can't choose Earth for your project. So we'll move right on to Mars, the fourth planet in the system. Mars is named after the god of war. I'm going to let you take a guess at that, maybe because of the color. Interesting about Mars temperature-wise, it actually is almost within what we call that Goldilocks range. Like Earth is right in the middle, what we were talking about yesterday. Mars is just on the end. So on a summer day in Mars, you're actually looking at plus 20 Celsius. I mean, if there was air to breathe, you could actually handle that. Now in the shade or in the winter, you're looking at a minus 120, like similar to other planets. And so, it has its problems. Also, Mars, half the size of the other planets. I remember talking about Mercury being just larger than the Moon, talked about Venus being the same size as Earth, while Mars, it's about half the size of Earth. So you're going to deal with a gravity situation there too, when people keep talking about future colonization. And another thing you should think about, because when you graduate and you get jobs, you may actually get a contract to work on Mars. If they do what they say they want to do, read the fine print, because Mars's orbit is twice as long as Earth's orbit. So if it says 2-year contract, but it says 2 Earth years, not 2 Mars years. The spin on Mars, very, very similar to Earth. So a day on Mars is only an extra 40 minutes. So it's one thing that, for humans, we could acclimatize to quite well. Okay, so those are the 4 terrestrial planets plus Earth, and I think you guys remember a lot of Earth, sorry, the 5 terrestrial planets. So any questions regarding those before we move on to the gas giants? Because okay, just a recap on terrestrials then. Rocky, if we had Google right now, get somebody in here to define that, the exact definition for me, has an atmosphere, most of them, because like I said, even Mercury, very, very trace amount. I mean, no real atmosphere because it's so close, but they're rocky, so they have a surface you can stand on, and they have some form of an atmosphere. Okay, let's move on now to gas giants, which are, as their name implies, gas and giant. The very first one is Jupiter. It's coming up just after Mars, so this is the largest planet in the solar system. You can almost see it as a failed startup to become a sun. If it had about 30 times more mass, it actually could have formed a small star. And then as you could guess, the atmosphere of Jupiter, very actually similar to the atmosphere of the sun. Hydrogen and helium, those are the 2 main components that make up the atmosphere. And looking at Jupiter, you would think maybe, it's a really hot planet because it has no cores of its own, but the actual clouds, you're looking at minus 120 up to minus 300 degrees Celsius. They're freezing cold clouds. It only gets warmer as you descend. But being a gas giant, there's no actual solid surface for which you stand on. So you would just keep sinking and sinking and sinking until you eventually just crushed under the gravity and melted under the heat once you got deep enough. Very common characteristics of gas giants, they spin really, really fast. To rotate on its axis, it takes Saturn 10 hours. That's how long it can spin on its axis in 10 hours. It's just amazingly fast. I mean, its orbital period, of course, is 29 years because it's much further out than the other planets. And as we talked about yesterday, the further out you go, the larger orbit you're just going to get. Yeah, a very interesting thing about Jupiter, which a lot of reports start to focus in on, the giant eye of Jupiter, the storm that's been raging for 300-some plus years. So a very interesting thing to dive deeper into. And the fact that Jupiter has 60-some odd moons. So when we get into moons next unit, some very interesting things that I will talk about or elaborate more on later. So the next planet after Jupiter is Saturn. Saturn is very, very, very common composition to Jupiter, and that it is mostly made up of helium and hydrogen. Saturn, I would say, beats Jupiter in the sense that it's more predominant, the rings. It's the first thing you think about, and those rings that are actually circling Saturn, they're just ice crystals and fine, fine dust particles. From a large distance, it almost looks like a solid object that you could skate on or something like that, but you can't. It's just ice and dust particles. Saturn size-wise, you're looking at not as big as Jupiter. Because like I said, Jupiter was the largest of all the planets. You can fit all the planets twice inside of it. Saturn, you could fit all the planets minus Jupiter inside of it. You could fit about, there's another way, 760 Earths you could fit inside Saturn. So if you were doing the research, Saturn also has 53 moons, something interesting to look at, but they don't have as many Earth-like environments on the moons as Jupiter does. So if you're looking into moons for your project, you would probably looking more to Jupiter than to Saturn. Now, the last 2 planets that make up the gas giants are Uranus and Neptune. The first one up is Uranus, about 4 times the size of Earth, just freezing, because once you pass that asteroid, once you get into the gas giants, the further out, you're just not really getting any more heat or energy from the sun. The sun is almost at this point just like a little bitty dot. So Uranus is mostly known for its blue tint. Like I said, 4 times the size, very cold planet, minus 216 degrees. The rotation period, still fast, like the other gas giants, takes 17 hours for Neptune to rotate. 84 years at this point for it to orbit, because we're just way farther out now. I was going to say, what's an interesting fact about Uranus that you may want to dig to is that majority of the mass is made up of a fluid mix of water, methane, and ammonia ice. So there's like seas of ammonia, just liquid floating around on there. Very interesting planet. We've never really actually had any probes there, but it's still good. Neptune, next planet up, very similar to Uranus, like I said, same temperature, minus 216 degrees. Only difference with this is you get this faint green tint to the planet, and that mostly just has to do with the methane that's in the atmosphere. Otherwise, the atmosphere has the same composition as Uranus. 16 hours for Neptune to spin, very similar to Uranus. Uranus was 17 hours. Orbital period, though, for Neptune, the furthest planet out, is by far the most prominent. 165 years for the orbit to occur, just vast. And okay, so are there any more questions now on gas giants, the last four there? Okay, this I want you to remember, because these are the two key terms you really need to know. You don't need to go into all the details of the temperatures and stuff. You just need to remember gas giants, no solid core, rocky planet, solid core. Okay, let's move on to the next subject.